Hello everyone, welcome back to my channel. Today I'm going to be giving a quick lecture introducing you guys to elimination reactions. So E1 and E2 reaction mechanisms and how they sort of differ from substitution ones. So SN1 and SN2 reactions. So in organic chemistry, you might encounter elimination or substitution reactions. In both of these reactions, we have some sort of leaving group. But what is generally the case is that substitution and elimination reactions will just compete with each other to give some mixture of products. So to start off, let's look at the different outcomes we might encounter when looking at substitution or elimination reactions. So let's look at the difference between substitution versus elimination reactions. Okay, so let's say we have some cyclic compound and it has a leaving group, bromine. We call the position of the carbon attached to the leaving group the alpha position, and then the beta position is just the carbon that's attached next to the leaving group. Let's look at a very general case where we have this compound reacting with a hydroxide group, so OH. If we were to look at this mechanism via a substitution reaction, what sort of product would we expect? Well, we would expect the hydroxide group to replace the leaving group, either via nucleophilic attack or via the formation of a carbocation. But in the case of a substitution reaction, what you will have, substitution reaction, what you will have is the leaving group being replaced by the nucleophile. What if we were to look at this same compound, but it traverses via an elimination reaction? Well, in an elimination reaction, the beta proton is removed and the leaving group is removed also, and a double bond is going to be formed between the alpha and beta position. So to summarize real quick, in a substitution reaction, we have a leaving group that's replaced with a nucleophile, In the case of an elimination reaction, we have a leaving group leaving as well as a beta proton leaving, and we have the formation of an alkene. In some subsequent videos, we'll be looking at whether products or whether reactions will proceed via a substitution or elimination reaction. But in real life, we'll generally see substitution and elimination reactions competing with each other to give some mixture of products. But to move on, let's take a look at E2 reaction mechanisms first. In an E2 reaction, we have a base and a substrate reacting with each other. The substrate I'll label here in blue. The substrate contains a leaving group here. Let me draw out the hydrogens associated with the substrate, just so we can take a look at the reaction mechanism a bit more clear. So in an E2 reaction, what we have is the base attacking this proton here. We call this step proton transfer because what we have is the proton being transferred to the base. This causes the formation of a double bond and the loss of a leaving group. So the product that is formed at the end of an E2 reaction is some alkene plus the leaving group species. So to summarize really quickly, in an E2 reaction, we have a base and a substrate reacting with each other. A proton is transferred to the base. So proton transfer occurs. Causing the formation of a double bond which causes the leaving group to leave. An important thing to note is that an E2 mechanism happens all in one step. So it's one mechanistic step. And there are no intermediates being formed. We also call this an E2 mechanism because there are two reactants, a base and a substrate, reacting with each other. So an E2 reaction is called a bimolecular elimination reaction. Let's now take a look at what an E1 reaction mechanism looks like. So let's move on to the E1 mechanism. In an E1 mechanism, there are two steps that are going to happen. So let me draw out a really basic example of an E1 mechanism. We have some compound here with a leaving group. What we have happening is the leaving group leaves. So the leaving group leaves. And we form a carbocation intermediate. Let me draw out the hydrogens on this end. So we form a carbocation intermediate. Then we have some base and a proton transfer occurs to form a double bond. So we end up with an alkene product here as well. So let's summarize really quickly what we see in an E1 mechanism. We have the loss of a leaving group, followed by proton transfer to the base. Actually, we have the loss of a leaving group, which forms a carbocation intermediate. A proton transfer then occurs via the base there, and this forms an alkene product. So this E1 reaction happens in 2 steps. Where a carbocation intermediate is formed in between. We also call an E1 reaction E1 because the 1 in the name suggests unimolecular elimination reaction. And it's unimolecular because it's not dependent on the concentration of the base. We just have the leaving group leaving all on its own. So in order for the reaction to start, we don't need to consider the concentration of the base at all, which is why we call it unimolecular. But that's the end of the lecture on elimination reactions, or introducing you guys to elimination reactions, how they differ from substitution reactions, the basic mechanisms for E1 and E2 reactions. In the next video, I'll go more in depth into E2 reaction mechanisms and also E1 reaction mechanisms, and how to predict the products of those types of reactions. But for now, thank you for watching and have a good day.